They burned the swamp, and what they found hiding underneath is going to change everything you think you know about this war. Not just snakes, not just dead grass and ash. Something far more disturbing. A revelation that has the scientists, the hunters, and the government all asking the same terrifying question. Have we been fighting this battle completely wrong for 30 years? And is the technology we just unleashed the only thing that can save what is left? Let us start with the fire, because that is where the story begins. The Florida Forest Service does not just burn the Everglades to clear dead vegetation. That is the cover story. The real reason is more desperate, more calculated, and more controversial than most people realize. They burn it because they are running out of options. They burn it because the enemy they are fighting is so perfectly evolved for this environment, so impossibly good at disappearing, that conventional hunting is essentially a gesture, a symbolic act. A way of pretending that thousands of people walking through Sawgrass with flashlights is somehow moving the needle against a population that could number anywhere between 100,000 and 300,000 animals. Think about that number for a moment. 300,000. The Florida Fish and Wildlife Conservation Commission has confirmed that more than 27,000 Burmese pythons have been removed from Florida since the year 2000. That sounds like progress, until you realize that researchers estimate only around 1% of pythons are ever detected or caught. 1%. That means for every single snake we have pulled out of that swamp over the last 26 years, there are roughly 99 more we never saw. We have been bailing out a sinking ship with a teaspoon and calling it a victory. So they burn. They take drip torches, dripping a mix of diesel and gasoline into the thick, dry sawgrass, and they light the Everglades on fire. Controlled burns, they call them. Prescribed fire. But what the fire reveals when the smoke clears is not just snakes. It is a landscape of horror. The ash tells the real story. When the grass burns away, you do not see a temporary scar. You see the crime scene that has been hidden underneath for decades. No raccoon tracks in the mud. No rabbit warrens along the canal edges. No wading birds in the shallows. No otters, no foxes, no possums, no bobcats. Just black earth, charred stubble, and the eerie, slow movement of the only creature that is still thriving out there. In some core python zones of the Everglades, the population of marsh rabbits has dropped by 99%. The raccoons, 99% gone. The opossums, the same. These are not species that are struggling. These are species that have been eaten. Completely, systematically consumed by an apex predator that has no natural enemies in this ecosystem, that never gets sick from what it eats, that can go 6 months without a meal by slowing its metabolism to almost nothing, and that can lay up to 100 eggs in a single clutch. The math of this invasion is not complicated. It is catastrophic. To understand how we got here, you have to go back to the 1980s and 1990s. Miami was the exotic pet capital of the world. Baby Burmese pythons were sold for $20 in pet shops across South Florida. They were cute. They were manageable at 20 inches long. People wrapped them around their arms at parties and posted photos. They curled around your wrist like a piece of jewelry. But the Burmese python is one of the largest snake species on the planet, and it never stops growing. That cute baby becomes a 6-footer in a year, then 8 feet, then 10, then 15, then 20. It starts looking at your cat the way you look at a sandwich. It costs a fortune to feed. It outgrows every tank you can buy. And so people drove to the edge of the Everglades, opened their cars, and let go. They thought they were setting it free. They were detonating a biological bomb with a very, very slow fuse. Then Hurricane Andrew hit in 1992. This is the moment that changed everything. Andrew was a Category 5 storm that detonated across South Florida like something out of a science fiction movie. It leveled breeding facilities, destroyed pet shops, shattered zoo enclosures. Nobody knows exactly how many snakes were released all at once, but they went into exactly the right place at exactly the right time. The Everglades was warm. It was wet. It was teeming with prey animals that had never evolved alongside a constrictor. It was, for a Burmese python, paradise. No predators, no diseases, no competition, just food, warmth, and space. The snakes bred. Then they bred again and again. And for years, almost nobody noticed. Pythons are ambush predators. They do not chase. They do not roar. They wait in the water for 30 minutes at a time without breathing, completely still, invisible against the roots and the mud. They can sit in the same spot for 3 days without moving, waiting for the right moment. By the time the scientific community realized the invasion had taken hold, it was already decades too late to stop it. The snakes had spread across the entire southern Everglades ecosystem. They had moved into the mangroves. They had been caught swimming between the Florida Keys, island to island, crossing open ocean. They had been found in suburban backyards in Homestead, coiled around pool pumps in Miami, discovered inside garages in neighborhoods that were farmland just 10 years ago. They are following the canal systems like highways, using the infrastructure of a human civilization to push further and further north. Hunters are not removing pythons randomly. They are removing the pythons that make mistakes, the ones that cross roads at dusk, the ones that bask on levees in daylight, the ones that linger near human activity. Every snake that gets caught is a snake that was, in some small way, careless. And every careless snake that dies takes its genes out of the population. What is left behind, after years and years of hunting pressure, is an increasingly cautious, increasingly intelligent, increasingly hidden population of snakes. We are doing exactly what selective breeding does, except we are selecting for the qualities we most do not want. Caution, patience, invisibility. We are making the ghost in the grass even more ghostly. Hunters are already seeing the behavioral changes. Snakes that used to cross roads are now crossing only in the pitch black of new moon nights, when human vision is nearly useless. Animals that used to bask openly are now staying deeper in cover. The population is shifting its activity patterns in direct response to human hunting pressure. This is evolution happening in real time, compressed from thousands of years into decades by the selection pressure we have accidentally applied. This is why the fire matters. Fire strips away the camouflage advantage completely. When the sawgrass burns and the ground turns to black ash, the intricate brown and tan pattern of a Burmese python's skin, which evolved specifically to mimic the dappled light and shadow of a tropical marsh, becomes completely useless. The snake goes from invisible to neon. It glows on the dark ground. It has nowhere to hide. And crucially, it has to move. Pythons are ectothermic. They depend entirely on their environment to regulate their body temperature. Exposed to direct sun beating down on black scorched earth with no thatch, no shade, no cool water nearby, a python cannot stay still. It has to search for new cover. And that movement, that desperate search, is exactly when humans can catch them. After a burn in Palm Beach County in April 2025, python sightings spiked by 15% in just 48 hours. The fire turned a needle in a haystack problem into a needle on a black table. But the window is narrow, because Florida grows fast. Within a week, green shoots are pushing up through the ash. Within 2 weeks, the cover is already returning. Within a month, a python could hide again as effectively as before, so the hunters have to move fast. Every day the grass grows taller is a day the battlefield shifts back to the enemy's advantage. This is where technology has become the decisive factor. Because human eyes alone in a 1.5 million acre ecosystem are never going to be enough. The math simply does not work. You cannot hire enough hunters to watch enough ground to make a meaningful dent in the population using flashlights and eyesight. You need tools that change the physics of the search. And in the last few years, the tools have arrived. The most immediate technology is thermal imaging mounted on drones. The U.S. Geological Survey is now testing new radio tracking technology mounted on small unmanned aircraft systems, specifically designed to locate pythons in the Everglades. The principle is straightforward, but the execution is extraordinary. Pythons are cold-blooded, which means they absorb heat from their environment. After basking or after a fire, their surface temperature is detectably different from the surrounding ground. A thermal camera mounted on a drone flying 300 feet above the burn zone can pick up the temperature differential and flag it on a screen on the ground. What used to require a trained hunter walking through knee-deep water, fighting mosquitoes, stepping over limestone holes, and hoping to spot a camouflaged snake from 6 feet away can now be identified from the air in seconds. The drone does not get tired. It does not slip in the mud. It does not miss the spot because the light was bad. It sees heat, and heat does not lie. But the real technological breakthrough that changes this war at a fundamental level is something you cannot see at all. It is environmental DNA, what scientists call eDNA. The University of Florida developed a pioneering DNA-based environmental monitoring test that can detect the presence of Burmese pythons in a water body without ever seeing the snake. When a python moves through water, it sheds microscopic traces of genetic material continuously: skin cells, mucus, waste. These traces disperse into the water column and can persist for days. Scientists collect water samples from canals and ponds, take them to a lab, and run a process called droplet digital PCR analysis. They can detect python DNA at concentrations so tiny they are essentially invisible, even when the snake itself is long gone from the area. The USGS tested this across 28 sites in the greater Everglades ecosystem and detected python DNA at 25 of them. 25 out of 28. The snakes were everywhere, even in places where hunters had never found one. This technology does something that visual hunting never could. It maps the invisible. It tells you not just where a snake is, but where snakes have been, how recently, and in what concentrations. Combined with the thermal drone footage after a burn, eDNA creates a hunting system that has 2 layers. The eDNA tells you which canals and water bodies to prioritize. The burned ground and the thermal camera tell you exactly where to look when you get there. Together, they are exponentially more effective than either method alone. The Conservancy of Southwest Florida has been running this program since 2013 and in the most recent season, it produced results that nobody in conservation history had seen before. Here is how it works. Biologists catch male Burmese pythons and surgically implant radio transmitters inside them. Then they release those males back into the wild. A male python during breeding season, which runs from November through April, has one overriding biological priority: find a female. He does not hide. He does not stay still. He follows the chemical trail of female pheromones across miles of sawgrass and swamp, leading the biologists directly to the breeding aggregations, the mating balls where multiple males cluster around a large, egg-laden female. These are the most valuable targets in the entire python elimination effort. A single breeding female carries an average of 70 eggs. Remove her before she lays, and you prevent 70 new pythons from entering the ecosystem. The biologists follow 40 radio-tagged scout snakes across 200 square miles of Collier County. The snakes do the searching. The biologists do the removing. Between November 2025 and April 2026, this program delivered its greatest season ever. The Conservancy of Southwest Florida removed 177 pythons from that 200 square mile area, weighing a combined 8,080 pounds, 4 tons of snake, the largest single-season biomass removal since the program started. Along with those snakes, they removed 4,100 eggs that would have hatched into 4,100 new predators by summer. The largest single python captured this season was a 17-foot, 153-pound female found by Scout Snake number 118, nicknamed Snaquin, in November 2025. 17 feet, 153 pounds. To give you scale, that is roughly the size of a telephone pole, and it was moving through the dark Florida marsh as silently as a shadow. The Florida Python Challenge, the annual competition run by the Florida Fish and Wildlife Conservation Commission and the South Florida Water Management District, also produced significant results in 2026. 907 participants from 30 U.S. states, Canada, and Vietnam converged on the Everglades for 10 days in July. Together, they removed 280 pythons. And the winner, veteran python hunter Tom Rahill, personally caught 96 snakes in those 10 days. 96. That is nearly one snake every 2.5 hours for 10 consecutive days in some of the most difficult terrain on Earth. He won the $10,000 grand prize and shattered the previous individual record by 36 snakes. In 2025, the previous champion, Taylor Stanberry, who made history as the first woman to win the competition, had caught 60 pythons. The numbers are going up. The technology, the tactics, and the incentives are all improving. Since the year 2000, more than 27,000 pythons have been removed from Florida and reported to wildlife authorities. It is the largest invasive snake removal effort in human history. Because here is the math that nobody wants to say out loud. If there are between 100,000 and 300,000 pythons in the Everglades and surrounding areas, and if the best year in history has produced roughly 748 removals in a single month through the most intensive, well-funded, technology-assisted effort ever assembled, then we are removing less than 1% of the population per year. The snakes breed faster than we remove them. A single female that escapes capture this year will produce 70 eggs. If even a fraction of those survive to adulthood, we have not moved backward. We have not stayed even. We have fallen further behind. The population is not collapsing. It is adapting. And some of the ways it is adapting are genuinely alarming. The climate is not helping. The Everglades is changing. The wet seasons are getting wetter, producing taller, denser sawgrass that gives the snakes even more cover to hide in. The dry seasons are getting hotter and more extreme, turning that same grass into tinder so volatile that controlled burns become unpredictable. If the peat soil, the actual organic foundation of the Everglades, catches fire during an uncontrolled burn, it does not just burn the surface. It burns downward. It consumes thousands of years of accumulated organic material. That damage does not heal on any human timescale. The land managers are walking a razor's edge every time they light a match. There are also wilder concerns being whispered in scientific circles. Concerns about evolutionary adaptation that most researchers are reluctant to say publicly, but that the evidence is beginning to support. The burn zones are turning the Everglades black for weeks at a time. If those burns happen year after year, season after season, they create consistent selection pressure for darker coloration in the python population. Melanistic variants, snakes with darker than normal pigmentation, already exist in Burmese python populations around the world. The gene is there in the population. All it needs is an environmental advantage to become dominant. If the burn zones favor darker snakes that are harder to see against charred earth, we may be selecting for exactly that mutation. The ash adapted python, a snake as dark as the ground it hides on, invisible against the very landscape we created to reveal it. Scientists are also concerned about the pheromone trap technology being developed to lure males out of the deep mangroves. The concept is to synthesize the chemical signature of a receptive female python and broadcast it across the swamp as a kind of olfactory trap. Males follow the scent and walk into capture stations. In theory, it is brilliant. But some researchers worry about the scale effects. Could concentrations of synthetic pheromone draw snakes from miles away, actually increasing the density of pythons in certain zones rather than reducing the population overall? Could we be ringing a dinner bell that reaches further than we can control? And then there's the gene drive conversation, which sits in a category beyond anything else being discussed. A gene drive is a genetic modification technology that, when inserted into a population of animals, spreads through that population far faster than normal inheritance would allow. The theoretical application is to modify pythons to produce only male offspring, or to carry a lethal genetic sequence that builds up over generations until reproduction collapses. Release enough modified animals, and within several generations, the modification has spread through the entire population and breeding stops. It sounds like a perfect biological weapon. Targeted, clean, species-specific. But the theories about failure modes read like science fiction. What if the modified gene does something unexpected? What if it jumps to a related species through the complex, unpredictable biochemistry of a tropical swamp? The native indigo snake, the Florida king snake, other species of the same broad taxonomic family could theoretically be affected. What if we accidentally trigger a cascading extinction of reptiles we are trying to protect? What if we create sterile pythons that live even longer than fertile ones because they spend no energy on reproduction and simply eat more, grow larger, and roam further with no biological clock pushing them toward any outcome other than endless consumption? The technology is real. The conversation is real. But nobody has yet found a way to guarantee the gene stays where you put it. And in the wild, guarantees are the first thing to disappear. So we burn, we scout, we fly drones, we test water for invisible genetic traces. We turn the snake's own biology against it by using its males as informants. We run competitions that draw 900 hunters from 30 states and other countries. We wrestle animals the size of telephone poles out of the mud with our bare hands. And every year we break new records. And every year, the snakes are still there, still breeding, still spreading, still eating the last of the raccoons and the rabbits and the deer and the wading birds in one of the most irreplaceable ecosystems on the planet. The fire is our most honest metaphor for this entire war. It strips away the pretense. It shows us the truth of what is out there. The burned ground does not just reveal the snakes, it reveals the scale of the predation, the silence where there should be sound, the absence where there should be life. When you walk through a burn zone in the Everglades and you see nothing moving in the mud, no tracks, no burrows, no eyes in the beam of your headlamp, you're not looking at an empty place. You're looking at a place that has been eaten hollow, and the thing that ate it is still out there in the unburned margins, in the deep canals where the fire cannot reach, in the suburban drainage ditches of Homestead and Miami, in the mangroves of Florida Bay, following the canals north toward a world that has never had to deal with a 20-foot constrictor in its backyard. The technology is getting better. The Scout Snake program is producing record results. The drones are finding animals that eyes alone never would. The eDNA is mapping the invisible network of python movement across the water table of South Florida. The hunters are getting smarter and more effective with every season. We are unquestionably fighting this battle better in 2026 than we were in 2006 or 1996 or 1986. The tools are better, the science is better, the funding is better. But the snake is also better. It has had 30 years to learn this swamp. It has had 30 years of our hunting pressure to evolve caution. It has had 30 years of unlimited prey, unlimited space, and unlimited warmth to build a population so large that even our best efforts remove only a fraction of a percent of it per year. We are fighting something that evolves faster than we can respond, in a terrain that favors the hider over the seeker, at a scale that makes our most heroic removal numbers look like a rounding error. The grass will grow back after every fire. It always does. The sawgrass has survived ice ages, hurricanes, and droughts. It will survive the burn. The question that has no comfortable answer, the question that sits at the heart of every conversation between every biologist and land manager and hunter and conservationist working in the Everglades today, is what will be hiding in the grass when it returns. Will the new technology finally tip the balance? Will the scout snakes and the thermal drones and the eDNA mapping and the gene drive research eventually add up to something that changes the math? Will some future version of this program, smarter and better funded and more technologically sophisticated than anything that exists today, finally find a way to collapse the python population the way the python collapsed the rabbit population? Or have we already lost? Has the window already closed? Are we now permanently managing an ecosystem that has been fundamentally altered by a monster we created using tools that are just good enough to prevent total collapse but not good enough to restore what was there before?